quadratic equations and factoring. An important calculation that is necessary when working with quadratics, or in fact any polynomial function, is called factoring. The process of factoring can be used to change a quadratic equation from standard form to factored form. So on the left, we have the factored form, x plus 4, x minus 1, and on the right, we have the expanded form, x squared plus 3x minus 4. So let's take a look at the relationship between factored form and expanded form. We'll start by looking at an expanded form example. Step number 1, you need to find the two numbers that multiplied to get the last digit 3, but add up to get the middle digit 4. Using these numbers, you multiplied to get the last digit 3. We found that 3 times 1 would be 3, but, 3 plus 1 is 4. So the digits are 3 and 1. Digits, another word for number. So we take our brackets that we saw in the factored form. We put the first factor of x plus 3, and we put the second factor of x plus 1. Completing the square. Now we're going to go from expanded form to factored form using another method. When we look closely at 6 and 9, we can see a special relationship. If we take the middle term 6, we divide 6 by 2, we get 3, and we know that 3 squared is 9. So this is called a perfect square, tri meaning 3, nomials meaning terms. Okay, so just to recap, since 6 divided by 2 is 3, and 3 squared is 9, this is a perfect square trinomial. So we know the factors are x plus 3 and x plus 3, and we can write them in the form x plus 3 squared. Oh, here's another example that looks like something we could do easily. Let's take a look. This is called the difference of squares. And in this example, you can see that x squared is a perfect square and 9 is a perfect square. So this is called the difference of squares. So how do we factor? Write our two sets of brackets. In the first set of brackets, put the square root of x squared. So we're going to write x and x. Then we're going to write the square root of 9, which is 3 and 3. In the first set of brackets, put the square root of each number, which we've just looked at, separated by the plus sign. So we get the factor x plus 3. But in the second set of brackets, we want the same values, x and 3, but because we have to get rid of that middle term, the numbers will be separated by the negative sign. And that will give us the factors x plus 3 and x minus 3. So be on the lookout for x squared minus 9, difference of squares. But how can you find out if the answers you got are in fact correct? Well, we know that we can move from factored form to expanded form and expanded form to factored form. So to check if your answer is correct, you would, if it's factored, you would expand it using FOIL. First, outer, inner, last. Okay, so x times x is x squared, is the outer, is the first. The outer is x times 1, which is 1x. The inner is 3 times x, which is plus 3x. And the last is 3 times 1. Then we collect like terms, and we will get x squared plus 4x plus 3. Let's check this one. Expand x plus 3, x minus 3. First terms, x times x, x squared. Outer terms, x times negative 3, negative 3x. Inner, 3 times x, 3x. Last, 3 times negative 3, negative 9. So our answer is x squared minus 9. Now, on the screen, you will notice that there's a little bit of a mistake there, and that plus 3 should be minus 3. So I put it in with red. Okay? One more. X plus 3, x plus 3. Outer, x squared. Inner, 3x. Outer, 3x. Last, 9. So this is a perfect square trinomial, and we get x squared plus 6x plus 9. Now, if all else fails, because there's a variety of factoring techniques I haven't gone into, you can always use the quadratic formula. And the quadratic formula is minus b plus or minus the square root of b squared minus 4ac all over 2a. But how do you use that? If we take the example y equals 3x squared plus 12x plus 10, a is the number of the first variable, 3. B is the number of the second variable, 12, and C is the last constant number, 10. We take those values and substitute it into the formula. This should always say y equals, but you can use x equals. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So as you can see, we take b, negative 12 plus or minus 12 squared minus 4 times 3 times 10, all divided by 2 times 3. We work that through negative 12 plus or minus the square root of 144 minus 120, all divided by 6. Negative 12 plus or minus the square root of 24, all divided by 6. Negative 12 plus or minus 2 square root 6, all divided by 6. So we can bring out negative 12 plus 2 times negative 6, divide by 6, and negative 12 minus 2 square root 6 divided by 6. So we have two choices. in simplest terms. Negative 6 plus square root 6 divided by 3, and that's in the exact form, but we can break it down into negative 1.18, which is an approximate form, or negative 6 minus square root 6 divided by 3, which is negative 2.81. And if we check our graph by graphing the function, we can find these values. Remember, factoring is the opposite of expanding. To check your work, expand your result and verify if you are correct.